All right, let's talk about the unsung hero of the internet, the router. It's this little box that basically makes our entire digital world go round. So, how does it actually work?
I mean, really think about that for a second. You click on a link, and in a blink of an eye, information from a server thousands of miles away just appears. How in the world does that happen? How does a tiny little packet of your data navigate the absolute chaos of the internet to find its 1 in a billion destination?
Well, the answer is all thanks to these things, routers. What you're looking at here is a pretty simple network, but this is the exact same principle that powers the entire global internet. Routers are the brains of the whole operation, making millions of tiny, brilliant decisions every single second to guide your data along. So, what is a router actually doing? Honestly, the best way to think about it is as the internet's traffic cop. It's standing at a busy intersection, just directing all the data, making sure everything gets exactly where it needs to go, as fast and as efficiently as possible. When you boil it all down, it's really about two key functions, thinking and then acting. First, the router has to think. It has to figure out the absolute best path for your data to take. Then, it has to act on that decision and actually send the data on its way. That's it. That's the core job of a router. So let's dig into that first part, path determination. This is the thinking part of the job. I mean, with practically infinite possibilities, how does a router even begin to decide which path is the best one?
It does this using something called a routing table. You can think of this as its own personal GPS for the entire internet. It's a digital map that holds all the known routes and directions to get your data from point A to point B. And how does it build this amazing map? Well, it starts locally. It automatically knows about any networks it's plugged directly into. Then, an administrator can manually add routes, which we call static routes. But the real magic is dynamic routing, where routers talk to each other and share what they know, constantly updating their maps. And if it has no idea where to send something, it uses a gateway of last resort, which is basically like saying, I don't know, but I'll send it to my bigger, smarter neighbor who probably does.
Okay, this brings up a really important question. The internet isn't a simple grid. It's a tangled, messy web. So what happens when a router's map has a few different options to get to the same general area? Which one does it choose?
Let's say you're sending an email to a friend in another country. The router might have a general route to that country, another route to their specific city, and maybe an even more specific route to their neighborhood. How does it pick the best one? It uses a beautifully simple but really powerful principle called the longest match rule. And it's exactly what it sounds like. The router will always choose the most specific route it has in its table.
Here's a great way to think about it. Imagine you're mailing a letter. You could just write California on it, and hey, it would probably get there eventually. Or you could be more specific and write Los Angeles, California. That's better. But the absolute best, most specific address is 90210 Los Angeles, California. The Postal Service is going to use that most detailed address every time. That's the longest match.
It's the exact same idea in networking. Specificity is measured by what's called a prefix length. That's the slash and the number you see here. The bigger the number, the more specific the route. So in this example, the router sees routes to the same general area, but it's going to pick /26 because it's the most detailed address it has. It's the longest match. All right, so the router has done its thinking. The decision has been made using the longest match rule. Now it's time to act. It's time for packet forwarding. So, in a tiny fraction of a millisecond, the router knows exactly where this packet needs to go next to get it just one step closer to its final home.
When a data packet arrives at a router, it really only has 3 possible fates. 1, if the destination is right here on a local connected network, the router just sends it directly to that device. Easy. 2, if the destination is out there on the internet somewhere, it forwards the packet to the next router in the chain. And 3, if the router looks at its map and has absolutely no route at all, well, it has no choice but to simply drop the packet.
And you can see that whole process right here. A packet comes in, the router checks its map for the longest, most specific match it can find. If it finds one, it forwards it, either to a local device or the next router. And if it comes up empty, that packet gets dropped. It's a simple but ruthless process. Now, all of this has to happen at absolutely blistering speeds. I mean, to support video streaming, online gaming, all the things we do, it has to be instantaneous. And because of that, the way routers forward packets has evolved like crazy over the years. See, the old way, what was called process switching, was painfully slow. The router's main brain, its CPU, had to look at and think about every single packet.
But modern routers, they use a wicked fast system where all the routes are pre-calculated and stored in a special table, making the lookup process almost instant.
And this visual says it all. On the left, with the old method, you can see how every packet had to go interrupt the CPU. It was a massive bottleneck, a total traffic jam. But on the right, with modern methods like Cisco Express Forwarding, it's a data superhighway. The packets fly right on through without ever bothering the main processor.
And that incredible leap in efficiency is the real secret behind why the modern internet feels so fast. It's why your 4K movie doesn't buffer, why your video call is crystal clear. It's just pure, raw forwarding efficiency.
Which, brings us right back to where we started. It really is all about those two simple but incredibly important jobs, determining the best path and then forwarding the packet. Everything we've talked about is just in service of doing those two things better, smarter, and a whole lot faster.
So next time you click a link or send a message, maybe just for a split second, you'll think about the incredible, invisible journey your data is about to take. A journey made possible by a chain reaction of billions of decisions, all orchestrated by these amazing traffic cops of the internet.